A thumb presses against the top of a Bic crystal cap. The pad of skin sinks slightly into a circular void no wider than a grain of coarse sand. 1.5 millimeters of nothing. A perforation so small, so utterly unremarkable, that 14 billion thumbs have pressed against it without a single conscious thought. The gesture is automatic. The question never arrives. And yet, that tiny absence of plastic is not a manufacturing defect, not a pressure valve, not a vent for drying ink. It is something far more specific and far more grim than any of those explanations suggest. The assumption has calcified into common knowledge. The hole exists to equalize air pressure between the inside and outside of the cap, preventing a vacuum from forming and pulling ink out of the cartridge. A neat little engineering story. The kind of explanation that spreads through office break rooms and internet forums with the quiet confidence of a fact no one bothers to verify. But place a sealed Bic crystal under a barometric chamber, drop the pressure by 40 hectopascals, and observe the ink reservoir. Nothing shifts. The tungsten carbide ball at the nib, seated in its brass housing with a tolerance of 5 micrometers, holds the viscous oil-based ink in place regardless of external pressure. The cap's seal is irrelevant to the cartridge's integrity. The hole changes nothing about the pen's function. So the question reforms, sharper now. If the perforation does not serve the ink, does not serve the pressure, does not serve the cap's grip or the pen's longevity, then what exactly does it serve? Why has Bic, headquartered in Clichy, France, maintained this precise geometric absence across every crystal cap produced since 1991? Why did the International Organization for Standardization codify its dimensions into a binding specification? Why do injection molding machines in Manaus, Mexico City, Bangkok, and Johannesburg stamp this identical circle into plastic roughly 45,000 times per hour, 6 days a week without pause? The answer is not mechanical. It is not chemical. It is anatomical. And it begins in the narrowest, most fragile tube inside the human body, a passage only 8 millimeters wide in a child, lined with soft pink tissue, designed for one purpose and one purpose only. A passage that, when blocked completely by a smooth cylinder of polystyrene, allows exactly 4 minutes of consciousness before irreversible damage sets in. 4 minutes. That is the entire margin between a minor choking scare and a closed casket. The hole in the cap was never engineered for the pen. It was engineered for the throat. Clichy, a commune on the northwestern edge of Paris, smelled of ink solvent and heated metal in the winter of 1945. Inside a modest workshop, Marcel Bitch, a 31-year-old former ink factory supervisor, registered a company called Société PPA, Port Plume, Port Mines, and Accessories. The ambition was narrow. The execution would not be. By December 1950, Bitch had refined a Hungarian ballpoint mechanism into a product so radically simple and inexpensive that it demolished every assumption about what a writing instrument should cost. The Bic Crystal. A transparent hexagonal barrel of polystyrene, a brass tip, a tungsten carbide ball, and a cap. A solid, airtight, completely sealed cap. For 4 decades, that cap remained unchanged. No hole, no perforation. A smooth thimble of colored plastic designed to protect the nib from dust and prevent ink from smearing inside a pocket. And for 4 decades, that smooth thimble fit precisely over the trachea of a small child. The geometry was accidental but lethal. The external diameter of a Bic crystal cap measures approximately 11 millimeters. The average tracheal diameter of a child between the ages of 3 and 7 falls between 8 and 10 millimeters. The cap does not merely lodge. It seals. The smooth inner wall of the polystyrene presses flush against the mucosal lining of the airway, and the vacuum created by the lungs' desperate downward pull tightens the grip with every attempted breath. No air passes. Not a trickle. Not a whisper. A total mechanical obstruction. Throughout the 1970s and 1980s, the United States Consumer Product Safety Commission logged approximately 100 choking fatalities per year attributed to pin caps and similar small cylindrical objects. 100. Every year. Most under the age of 5. Most occurring in classrooms, living rooms, and back seats of cars. Environments so ordinary that the object in the mouth registered as nothing more than a habit, a fidget, a momentary distraction. Then, in 1991, Bic altered the mold. A single perforation, 1.5 millimeters in diameter, punched through the apex of every crystal cap, leaving the Clichy production line. The ink formula did not change. The barrel did not change. The ballpoint mechanism did not change. Only the cap breathed now. And the reason it breathed had nothing to do with the pen. It breathed because a human trachea, when sealed shut by smooth plastic, begins to die in roughly 240 seconds. The specification arrived 4 years after Bic's redesign, formalized in Geneva by the International Organization for Standardization under the designation ISO 11540. The document is brief. Its central requirement is not. Any writing instrument cap with an external diameter below 50 millimeters must permit a minimum airflow of 8 liters per minute when the cap is fully obstructing a standardized test cylinder. 8 liters? Roughly the volume of 2 collapsed aluminum soda cans pushed through a channel no wider than a drinking straw every 60 seconds. That is the minimum threshold between suffocation and survival. The engineering behind the number is brutally straightforward. A child's trachea, when completely blocked by a solid cap, creates a sealed column of stagnant air. The diaphragm contracts. The lungs expand. Pressure drops below atmospheric. The cap is sucked tighter. With each successive breath attempt, the seal strengthens. Within 90 seconds, blood oxygen saturation falls below 60%. Within 4 minutes, neurons in the cerebral cortex begin irreversible apoptosis. The perforation breaks this cascade. Even when the cap is fully lodged, the 1.5 millimeter channel allows ambient air to bypass the obstruction. 8 liters per minute is not enough to sustain consciousness indefinitely. It is enough to extend the window from 4 minutes to over an hour. Enough time for an adult to notice. Enough time for the Heimlich maneuver. Enough time to reach an emergency ward. The manufacturing tolerance is unforgiving. Bic's injection molding dies in Clichy hold the perforation diameter to plus or minus 0.2 millimeters. Too small, and the airflow drops below the ISO threshold. Too large, and the cap loses its ability to protect the nib from particulate contamination, degrading the tungsten carbide ball over time. The whole exists in a narrow corridor of precision, balanced between keeping a child alive and keeping a pen functional. Rival manufacturers followed at uneven speeds. Papermate, owned by Newell Brands, adopted ventilated caps by 1994. Pilot Corporation in Tokyo integrated the perforation into its G2 and V5 lines by 1996. Stettler and Nuremberg complied by 1998. Each transition required retooling hardened steel injection molds at a cost ranging from $40,000 to $120,000 per die set. For a company producing 400 million caps annually, the retooling cascade ran into the millions. Yet the specification held. ISO 11540 was revised in 2014, tightening the test protocol but preserving the 8-liter minimum. The standard now carries legal weight in the European Union, Australia, Japan, and South Korea. Non-compliance triggers product recalls, import bans, and civil liability. One small circle of absence, machined into steel, replicated in polystyrene, and enforced across 6 continents by treaty. And yet, the most staggering part of this story has not yet been measured. Not in liters per minute, not in millimeters of tolerance. In something far larger, far more numerous, and far more indifferent to the single perforation that governs it. 14 billion! That is the number of Bic crystal units manufactured every 12 months across facilities in Clichy, Manaus, Toluca, Durban, and Rayong. 14 billion transparent hexagonal barrels, 14 billion brass-tipped nibs, and 14 billion small polystyrene caps, each one carrying the identical 1.5 millimeter hole at its apex. The production lines never stop. In Manaus alone, injection molding machines cycle every 3.2 seconds, ejecting a finished cap into a steel chute with a soft plastic clatter that repeats 27,000 times per shift. Multiply that rhythm across 5 continents, 365 days, and the sheer industrial gravity of the perforation becomes almost incomprehensible. Now remove it. Run the hypothetical. 14 billion solid caps, smooth and sealed, flooding classrooms in Lagos, offices in São Paulo, kitchen tables in Osaka, back seats of sedans in Ohio. A child lifts the cap to the mouth. Teeth click against polystyrene. The cap slips past the tongue, past the epiglottis, and wedges into the trachea with a soft, wet click. The seal is instant. The diaphragm heaves. Nothing moves. No air. No sound. The lips begin to darken at the edges. 4 minutes. That is the entire architecture of time, separating the click from the collapse. 240 seconds, in which a single perforation, 1.5 millimeters wide, is the only structural difference between a coughing fit and a funeral. The statistics confirm the weight of that difference. Between 1992 and 2005, the Consumer Product Safety Commission recorded a 63% decline in pen cap-related choking fatalities among children under 14 in the United States. The drop correlated directly with the market penetration of ventilated caps. In the European Union, post-ISO 11540 surveillance data showed a similar trajectory. The perforation worked. Not perfectly, not in every case, but across billions of units and billions of unconscious chewing habits, the absence of plastic where plastic once sealed shut translated into thousands of airways remaining open. Thousands of small chests continuing to rise and fall. thousands of 4-minute windows stretched into survivable hours. And the economic machinery behind that single hole is itself staggering. Retooling a single hardened steel injection mold costs between $40,000 and $120,000. BIC operates over 200 active mold sets across 5 countries. The cumulative capital expenditure to integrate the perforation globally, adjusted for inflation to 2026 figures, exceeds $28 million. $28 million spent not to improve the pen, not to extend ink life, not to reduce manufacturing defects. Spent entirely to ensure that if the worst possible moment arrives, if the cap slips, if the throat closes, if the silence falls, a channel no wider than a pinhead will hold the line between breath and void. The hole costs nothing to the consumer. It is invisible in the hand. It registers as nothing. And that invisibility is, in itself, the final and most unsettling layer of the story. The perforation does not help the ink. This is now absolute. It does not regulate pressure. It does not prevent the tungsten carbide ball from drying. It does not assist the cap's grip on the barrel. It contributes nothing to the writing experience, nothing to the shelf life, nothing to the mechanical function of the Bic Cristal or any other ventilated pen produced under ISO 1154. The whole exists for one scenario, one configuration of flesh and plastic, one terrible geometry in which a smooth cylinder seals a child's airway and the lungs begin to starve. It exists for the worst moment. And in every other moment, the billions upon billions of other moments in which the cap sits in a pocket, clips to a notebook, or rolls across a desk, the whole does nothing. It is a feature designed to be unnecessary. A solution engineered to be ignored. And yet, it is there. In 14 billion caps per year. In every classroom in Mumbai, every office in Berlin, every kitchen drawer in Buenos Aires. Machined into hardened steel dies in Clichy, replicated in polystyrene in Manaus, stamped in Toluca, molded in Rayong. The same 1.5 millimeters. The same 8 liters per minute. The same silent, invisible covenant between a manufacturing specification and a small, open airway. The same 1991 dimension, unchanged for 35 years, because the diameter of a child's trachea has not changed, and the physics of suffocation have not changed, and the 4-minute window between breath and brain death has not changed. There is a particular cruelty in invisible safety. The seatbelt that never tightens. The airbag that never deploys. The fire exit never pushed open. The perforation in the pen cap that never needs to channel 8 liters of air through a sealed throat. These are designs whose entire purpose is to remain unused, untested, unacknowledged. They carry no prestige. They earn no gratitude. They are invisible, not because they are unimportant, but because their success is measured in events that never occur. In breaths that continue without interruption. In afternoons that pass without an ambulance. The pen cap rests on a school desk. Late afternoon light catches its surface, and for a single instant the whole is visible, a dark, perfect circle, no wider than a grain of sand, catching the light like a small, open eye. It asks nothing. It explains nothing. It simply holds its shape 14 billion times over, waiting in every pocket and pencil case across the planet for a moment it was built to meet, and prays it never will. And somewhere, In the silence between one breath and the next, that tiny absence of plastic is the only thing standing between a child's lungs and the dark.